welcome. Um, I hope you are ready. We're going to take one question on finding the derivative of a function, but we're going to focus on a chain rule, or we can call it a function of a function. So we're going to find the derivative using the chain rule. So using the function of a function, a rule, or we can call it the chain rule. Okay, so we typically use the function of a function rule when there's a derivative that we can get right from the derivative rules, and then we apply the function of a function rule. So the function of a function rule says if I want dy over dx of a function, that can be du over dx multiplied by dy over dx. Okay, so let's say you're given y in terms of 1 over 4, the sec of 4x. This is a function of a function because directly from the rules we cannot get a derivative of sec of kx, so we can apply the rules in our case. Okay, so step number 1, we will let u be equals to this function there, which is 4x, and then we find the derivative of that function with respect to x. So du over dx is equals to 4. So at that point our y becomes 1 over 4 the sec of u. So if that's the case, we can find dy with respect to du of that function, 1 over 4. So the derivative of sec, that will be sec of u multiplied by the tan of u. So now we have du over dx and we have dy over du. We can go back into the function of a function rule and find our derivative. So the derivative dy over dx will be du over dx multiplying with dy over du. Okay, so dy over du, I think this was an omission there. Okay, so du over dx, we've calculated du over dx as 4, so we're going to multiply 4 with 1 over 4 times sec of u and tan of u. So that is 1 over 4 times sec u times the tan of u. So we're at the point now, when you multiply 4 into the bracket, we get sec of u multiplied by tan of u, and then we can replace u back as 4x. So that will give us sec of 4x multiplied by the tan of 4x. So that is our dy over dx. Okay. Now let's go to another one, which is a much more complicated. We need to differentiate, so I'll use the red again. Differentiate. Let's differentiate with respect to x. If we have the following, we've got a long one. Y is given as the log of 2 the log of x minus the tan of 2x minus 3 r to the power of 2x plus x to the power of minus 2x, or minus 2, sorry, minus 3 to the power of minus 2x plus 9x plus 6. Quite a mouthful. Okay. Right, so let's quickly dissect this question. Here on the second term, we do have a function of a function. We also have a function of a function on the third term, right here. We have a function of a function on term number 5. So 1, 2, 3, 4, 5. So these three, if you are in a position, you can just take them aside and use a function of a function rule to get the derivatives of each. Okay, so I'm gonna try to use them aside and then get the derivative of each. So I'll just denote them as tan of 2x and the derivative of it. So let me just write it as a denote of, let's say it's k is tan of 2x, then the derivative of that would be, firstly we derive, so a shorter way is derive what is the tan of 2x, what is the tan, the derivative of tan is sec squared of the same function multiplying with the derivative of that function with respect to x, so that will give us 2. And then let's make another one. So let's take r, let's call this one k, yeah, let's call this one v is given as 3 r to the power of 2x. Derivative of v is going to be 3, alright, multiplying with r to the power of 2x, the ln of r multiplied by the derivative of that exponent, which is 2. Okay, let's also do this one separately. Let's call this one w, which is 3 to the power of minus 2x, and the derivative of w is going to give us 3, okay, to the power of minus 2x, the ln of 3 multiplying by the derivative of the exponent, the function there, with respect to x. That will give us minus 2. I've done this separately so that you can get the idea that you are going to be required to identify this is a function of a function, this is a function of a function, that is a function of a function, or this is a chain rule, this is chain rule, this is chain rule separately. And I've omitted the signs in front of it just for simplicity's sake. So when we continue, we're going to plug all of them in there when we find our derivatives. So the derivative of y, okay, so we're going to find the derivative of that to the log of x. So in our case, that's a base of 10. So we'll have 2 multiplying by 1 over x, the ln function of 10, minus, so we're going to plug this one in there. So we can say this is 2 sec squared to x. That's the derivative of that one, which is our k, and the derivative of minus v. So we've got minus, so let's say minus minus 3 times 2 r to the power of 2x, the ln of r. Okay, then we need to derive number 4. Term number 4 is x to the power of minus 2. The derivative of that is minus 2x to the power of minus 3. Then derive the fifth term, which is also a function of a function. So that will give us, so we've got minus and minus, so let's call this one positive 2 multiplying by 3 to the power of minus 2x, the ln of 3, plus the derivative of 9x will give us 9, and then the derivative of a constant will give us 0. So writing this one down out, that will be 2 over x, the ln of 10, minus 2 sec squared of 2x, minus, so that's 3 times 2r to the power of 2x, the ln of r, minus 2 over x to the power of 3, plus 2 multiplied by 3 to the power of minus 2x, the ln of 3, plus 9. I hope you find this very, very informative, and I hope to see you on another video. Cheers and thank you. Bye bye.